Hi guys, I'm Davis.
I'm Chris.
And I'm Jonathan.
And this is our math project. Our math project is on hyperbolic trig
functions.
functions. Let's get going.
Hey Davis, what shape is this?
What shape? That's a lot. A parabola.
Actually, I'm going to have to mark you incorrect on that one. This is actually a hyperbolic trig function.
Okay.
Specifically, it's a hyperbolic cosine function.
Well, I have a friend that's actually an expert on these. Let's welcome Jonathan Yoon, everyone. So Jonathan, what would be the origin of hyperbolic trig functions?
Well, Davis, hyperbolic trig functions were first introduced in the 1760s independently by two mathematicians, Vincenzo and Johann Lambert. Now, the functions are primarily consistent of sinh x and cos x, where sinh x is half the difference between e to the x and e to the negative x, and cos x is the average of the two.
Huh. So why would these be useful?
Well, as it turns out, cos x is the graph of something called a catenary, which can be used to closely model real-life things such as the physics of a hand rope between 2 points.
I was recently learning in calculus that I can approximate most things with a Taylor polynomial that's like an infinite thing and it keeps going and it can approximate things really well. Can you do this with like these hyperbolic stuff?
Yeah, of course.
Really?
Yeah, so you just take we know the Taylor series for e to the x, and we know the Taylor series for negative e to negative x based off of e to the x. We just combine these two and get the answer.
These hyperbolic trig functions, do they have any uses, like ever, or is it just something some guy wanted to make up to get his name on something?
As a matter of fact, a lot of Gothic architecture bases their models upon catenaries.
Catenary? Math? Modeling real-world things? I don't think so. It's right behind me, isn't it? So where are we going again?
I think we're gonna go find some catenaries.
All right, buckle up. Let's get cracking. Think about the music. You think this is perfect catenary finding music?
Yeah, not really, Davis.
No?
No, not really.
Okay.
Okay.
Let me go to the next one. No. One more.
Next.
No. Okay, next one.
Next one.
There we go.
Yeah. Oh look, we found a catenary! Yo.
愁对解小妹，泪洒相思带。
Jonathan, we have a problem.
Yeah.
Our 120-foot rope isn't touching the ground, and these poles that are 50 foot high from the ground, like, just won't stay. How far should we put them apart? Like,
Oh, well, I have a solution.
let's see it, Chris.
Let's do some math.
Yeah. Okay.
Yeah.
So now we need to find the distance that Davis and Jonathan need to stand apart so that the rope will touch the ground. First, we have the equation of the catenary. Y equals cosine h x over a times a. However, because in our specific equation, we want the x point at x equals y point at x equals 0 to equal to 0, we've modified the equation. So it's y equals a cosine h x over a minus a. And this works because when x equals 0, cosine h equals 1. This means that a times 1 minus a equals 0. So at x equals 0, y will also be 0. Next, we also know that the cable is 120 feet long. So from here to here, it's 120 feet long. And so from the top of Davis's pole to the ground, it's 60 feet long. And we also know that the pole that Davis and Jonathan is holding is 50 feet long as well. Next, we have this equation for arc length that we've learned this year in calculus. So we know this is the equation for arc length, and we happen to know that the arc length from the top of Davis's pole to the ground is 60 feet long. We also have the equation y equals a cosine h x over a minus a. What we don't know is the x value for that from 0 to this x value. Exactly what's the length that will allow this distance to equal 60. We also know that y equals 50 since the height of the pole is 50 feet. So let's do some math. If you plug the arc length equation into a calculator, we'll get the answer that the integral from 0 to x of square root of 1 plus dy over dt squared equals a sine h of x over a. So from this we know that a sine h of x over a is equal to 60 since that's the arc length. We also know that y equals 50, so we can plug this into the original equation of y equals a cosine h x over a minus a. We get the equation 50 equals a cosine h x over a minus a. Next, we know that cosine h squared x over a minus sine h squared x over a equals 1 because it's a hyperbolic trig identity. And so we can simplify the equations, plug it in, we get the value that a equals 11. However, a is merely a modifier. It isn't the actual answer. And so since we know that y equals 50 and we have the a value, we just plug this into a calculator to find the x value. Turns out the x value from Davis to the ground is 26.377 feet. However, to find the distance from Davis to Jonathan, we need to multiply that by 2. So the final answer, Davis and Jonathan need to stand 52.75 feet apart in order for the rope to touch the ground.
So what was I supposed to learn again?
Well, hyperbolic trig functions are composed of e to the x and e to the negative x.
And specifically, hyperbolic cosine models a free hanging object like a rope or all the catenaries we saw. And finally, hyperbolic trig functions are not parabolas.
Now that's cool.